Good morning, everyone. My name is Zofia GRÓDEK-SZOSTAK. I work in Department of Economics and Enterprise Organization, Krakow University of Economics. The subject of my virtual presentation is EU's energy transformation towards an increased share of renewable energy. The challenges related to global climate were first tackled at the European Union level in 2000. When the European Commission established the European Climate Change Programme. The important instrument is reducing EU greenhouse gas emissions were the newly established pollution emissions market, introducing the mandatory share of renewable energy and increasing energy efficiency. In particular, the EU climate policy addressed to energy sector, which is mainly responsible, apart from transport, for GHG emissions. Therefore, the effectiveness of climate change depends on the restructuring of the energy sector, especially the selection of renewable energy sources and the efficiency of combustion processes. The source of the data used of the analysis in the empirical part is the European Environment Agency and the European Statistical System. The research sample in an index of the share of renewable energy in a gross final power consumption expressed as the percentage. Empirical data come from the years 2004 to 2018 and a single time series includes 15 observations. Data were presented for all EU member states as well as Great Britain, Iceland, Norway, Albania, Montenegro, North Macedonia and Turkey. In total, 36 countries were studied. The data was checked for possible discontinuous and errors. To minimize the impact of arbitrary interventions of the obtained results, no correcting or supplementing procedures were applied to empirical data. The index therefore measures the level of renewable energy use and consequently the extent to which renewable fuels have replaced fossil and or nuclear fuels, those contributing to the decarbonization of the EU's economy. It also shows progress towards the Europe 2020 renewable energy source target at the general level by increasing the share of renewable energy in gross final energy consumption to 20% by 2020. To better illustrate the situation, Figure 1 presents the behavior of the share of renewable energy in final energy consumption for all 36 countries. The presentation for all countries in one figure undoubtedly allows a comparison of the index for all countries, but becomes difficult to read, especially in the middle part of the chart. However, it can be observed that countries such as Iceland, Norway, as well as Sweden and Montenegro have the highest rates of renewable energy use in gross final energy consumption. On the other hand, Malta, Luxembourg, Great Britain and Netherlands, Ireland, Cyprus and Belgium rank last in classification. Poland, which indicators at 10%, is just ahead of them. As mentioned above, the figure compiling all analyzed countries is illegible. Therefore, to more accurately illustrate the study phenomenon in connection with the geographical location, the authors decide to present graphic illustration in a subsection into 5 groups. For example, Western Europe, Central Europe, Northern Europe, Eastern Europe, and Mediterranean Europe. As showing in a chart in Figure 2, among the countries of Western Europe, France has the highest rates of renewable energy share in final energy consumption, but it also be seen that even France has not met the strategic goal set by European Union in 2018, for example, reaching the 20% ratio level. Only on the other hand, when analyzing the Central European countries shown in a figure, it can be observed that Austria achieved the highest share of renewable energy in final energy consumption, and Slovenia ranks second. It is worth noting that only these two countries in the region meet the strategic target set by the EU, approx 30% for Austria and 20% for Slovenia, respectively, and they did so already in 2018. The remaining Central European countries are not commentable in terms of the level of the discussed index, and Poland and Slovakia rank the worst. Figure presents the rate of the share of renewable energy in final energy consumption among the countries of Northern Europe. It is the only region in Europe where all countries have exceeded the 20% level of the indicator already in 2018. The indicators of Iceland and Norway will reach the highest value, approx 70%, while Denmark's lowest also satisfactory from the EU's point of view, above 30%. Also, all Eastern European countries have met the strategic goals set by the European Union, for example, the 20% rate of renewable energy share in final energy consumption by 2020. However, in Bulgaria, it was only in 2018. As shown figure, Latvia has the highest value of the index, but these numbers are not as spectacular in this case of Northern European countries since they are below 30%. The lowest index in that of the above mentioned Bulgaria. Out of 13 Mediterranean European countries, only 6 have achieved the strategic EU target for 20% share of renewable energy in final energy consumption by 2020. Montenegro, Albania, Portugal, Croatia, Kosovo and Serbia, as shown in the figure. Among all the countries in geographical zone, Malta and Cyprus recorded the lowest value of the index. In a subject literature, the trend function described past regulates shaped by particularly strong and lasting causes that acted in a period covered by the study. The estimated trend function can be used to forecast the development of the studied phenomenon in subsequent period. The purpose of this subchapter is to find the best suited trend function to illustrate the share of renewable energy consumption in gross final energy consumption, and then to forecast the development of the analyzed phenomenon in subsequent years for each of the discussed time. For each of the considered countries, the result of the analysis are presented on a table. Apart from the values of the estimated parameters and their means estimation errors given in parentheses, the table offers value of the coefficient of determination. As illustrated by data in a table on a slide, 4 out of the 7 trend models used in a process of estimating the share of renewable energy consumption in gross final energy consumption proved to be helpful: linear trend, square trend, cubic trend, and exponential trend. As shown by the result, apart from the free term of the cubic trend of model for Luxembourg, all estimates of parameters of the obtained model turned out to be statistically significant. The vast majority of the theoretical models describe the empirical observation quite well, as evidenced by highest value of the coefficient of determination. The models of Ireland, Austria, Denmark, Germany, Sweden and Malta were the best fit, with the coefficient of determination at 0.99 and more. Generally, out of the 36 analyzed countries, only the Albania, Slovenia, Macedonia and Turkey, the coefficient was below 0.8 but above 0.65. Therefore, in the case of these 4 countries, the forecast results should be treated with some caution. On the other hand, for Iceland, Kosovo, Serbia, Montenegro and Latvia, The coefficient of determination range above 0.8 but below 0.9, which still proves a very good adjustment of theoretical models to empirical data. One of the most popular tests for the stability of regression model parameters is the test developed in 1960s by economist G. Chou's test for structural change. Unfortunately, it is used to detect structural change only in the large samples. So in the case of empirical studies, as in the case of this manuscript, it cannot be applied due to insufficient number of observations. In many situations, another inconvenience of the Chou test that the hypothesis turning point, for example, the moment of time that divides the period into two subsamples, must be indicated. In this situation, it seems that the Accusiom test accumulated sum of results. That is appropriate here. Proposed by Brown, Durbin, and Evans in 1975, it verifies the hypothesis model stability without the need to indicate a turning point. The test produced results in textual and graphical forms. The Accusiom graph consists of the target. In a graph does not exist their hold values. For example, the red lines, it means that the model can be considered stable. The Accusiom test was conducted for the discussed 36 countries. Due to the volume of research, this manuscript presents an exemplary result for tests for a selected country, for example, Slovenia, as shown in a slide. The country was selected for the presentation of result for this country was decided by the fact that, as observed, the parameters of the model changed slightly, but only in 2008. The conducted test shown that, except for Slovenia, for all other countries in 2004 to 2018, the models appeared to stable. Only in the case of Serbia in 2008 and Iceland in 2006, the stability of the models in the indicated years was their false value. The formal part of the process of assessing the achievement of the renewable energy source target at the European Committee's decision to possible consequences will start in 2022. The legal foundation will be two documents. The first is the final summary of the share of renewable energy source in the energy mix for 2020, which will be published in European Statistical Office Eurostat in early 2022. The second are reports on the implementation of national renewable energy targets, which each EU country will have to submit by the end of April 2022. The Renewable Energy Directive does not indicate sanctions for failure to meet the 2020 target, and the committee is not planning to publish any guidelines to be followed in such a case. A potential consequence for countries lagging behind in meeting the 2020 targets should be understood rather as a means to intensify the effort and to increase the ambition to achieve the second EU renewable energy source target, the one set in a 2030 horizon. It responds to the challenge of the United Nations 2013 Agenda for Sustainable Development and the 2015 goals. The EU has developed the European Green Deal, which aims to further mitigate climate change by 2050 and deliver clean, safe and affordable power. This is a challenge for EU member states, including Poland, and its coal-based power sector, as changing this structure requires capital-intensive and time-consuming investment. This presentation and publication was financed by subsidy granted to Kraków University of Economics. Thank you very much.